Hey guys, so today we're going to talk about conditional probability. So conditional probability is the probability that an event B will occur given that another event A has already occurred. And we would denote this as the probability of B given A. This line means given. Now, a lot of this information or data is given in what we call a contingency table, which is also called a two-way frequency table. And it's basically just a table that contains data from two or more categories. All right, so let's look at this first table. We're going to find the probability. The table shows students by gender and type of school in 2005. You pick a student at random. What is the probability that they are female given they are graduate school? So it is given that they are in graduate school. So this means we are only looking at the people that are in graduate school. So we are only looking at these two groups of people. Whatever is given is what's limiting your sample space. Now, let's find the probability that they are female, given that they're in graduate school. Well, your probability that they're female, there's 1,954 over our total graduate school. So this would be the sum of 1,349 plus 1,954. So when we add these, we get 1,954 over 3,303, which gives us 0.592, 5916, which is approximately 59%. Now part B is asking what's the probability that they're female. So here, we're not given anything. We're not limiting our sample space. So we're going to find all females over all students. So if I add up all of my females, I should get 9,933 over all of the students, which is 17,472. So when we divide this, we get 0.5685, which is approximately 57%. So you're going to use the same table from the previous one. You're going to try, you try. So go ahead and pause the video and try these you try problems. All right, check your answers. You're finding the probability 4 years given that they're male. So you're looking at, it's given that they're male. So you're only looking at the males here. So you're only looking at this group. So what's the probability that they're in a 4-year college? Well, it would be this number over the total. So 4,324 over the total males. And it should equal out to approximately 57%. Then part B, without calculating, given a student is enrolled in 4-year college, is it more likely that they're male or female? Female, because there's more females in 4-year colleges than males. Americans recycle increasing amounts through municipal waste collection. The table shows the collection data for 2007. What is the probability that a sample of recycled waste is paper? So here, a probability that a sample of recycled waste is paper. So we are finding the probability that something is paper given that it's been recycled. So if it's given that it's been recycled, we're looking at the recycled category. And the probability that it's paper, well, there's 445.2 million tons of paper over all of our recycled. So 45.2 plus 7.2 plus 3.2 plus 2.1 plus 21.7. And when we add up all of this on the denominator, we should get 79.4. So that when we divide it, we get 0.5692, which is approximately 57%. So go ahead and pause the video and try the U-tries. Please pay attention to what it is a sample of, what is your given. So pause the video and try these U-tries. So go ahead and check your answers. Notice that the first two kind of follow the same pattern, is that it was recycled material. It was given that it was recycled. Now our second one was a sample of metal. So we are only looking at the metal. So the total metal is going to go on our denominator. Now we do have a formula that we can use to find this conditional probability. So it is the probability of B given A is the probability of A and B divided by the probability of A. And remember, our A is our given. So this is, the line again means given. So it's B given A. So it's the probability that both are happening over the probability of your given. Now, you can use this formula. Generally, you'll use it to when you're given other probabilities and not necessarily given other values, but you can use it whenever. So problem 3, a utility company asked 50 of its customers whether they pay their bill online or by mail. What is the probability that the customer pays the bill online given that they are male? So it is given that the customer is male. So we are finding the probability that they pay online given that they're male. So we are only looking at the males here. So we are only looking at this group of people. So from this group of people, the probability that they pay online is 12 out of 20. I'm not even looking at the females because it's given that they're male. So this is going to equal 12 over my total, so 12 plus 8. So this is 12 over 20, which is 0.6. Let's go ahead and pause the video and try the U-try problem. Go ahead and pause the video and try the U-try problem. So go ahead and check your answer. It's given that they're females, so that means we're only looking at the females. So we can basically cross off the males here. So the probability that they pour directly on their head, 6 out of 6 plus 24, so 6 out of 30, which is 0.2. This next slide is to build our tree diagram that's described in part 4. So part 4, the school system compiled the following information from a survey it sent to juniors who were juniors 10 years earlier. So our first one, 85% of students graduated from high school. So here we have some starting point when we create a tree diagram, and it said that 85% graduate. So we're breaking it into 2 categories. You can either graduate or you could not graduate. And it says that 85% graduate. So our graduate branch is going to have a value of 0.85, which means our not graduate branch is going to have a value of 0.15. So they add up to 50%. Or excuse me, add up to 100%. So our next bullet point says that of the students who graduated from high school, 90% are happy with their present job. So now we're looking off the graduate branch. So out of the graduates, 90% are happy. So off my graduate branch, I'm going to split it into 2 branches again. So you can either be happy with your current job, or you could be not happy. Now it said that 80% are happy. So this happy branch, or excuse me, 90% are happy. So my happy branch has a value of 0.9, which means my not happy branch has a value of 0.10. Our last bullet point said of the students who did not graduate from high school, 60% are happy with their current job. So off my not graduate branch, I'm going to break this into happy and not happy. So if you do not graduate, you could either be happy or you could be not happy. Now it said that the not graduates are happy 60%. So this value of this branch is 0.60, which means the value of the other branch is 0.40. Now, while our tree diagram is technically correct, we want these values off to the side, which is the probability of each branch happening. So the probability that they graduate and are happy. Remember, and means to multiply. So the probability that they graduate and are happy, I'm going to multiply 0.8 times 0.9 to means that the value of this branch would be 0.765. So then the probability that somebody graduates and is not happy, 0.85 times 0.10, would be 0.085. The probability that somebody did not graduate and is happy would be 0.15 times 0.60, which would give me 0.09. And then the probability somebody did not graduate and is not happy, this would give me a value of 0.06. So what these values tells us is the probability for all out of everybody. So the probability that they're happy and graduated out of the entire population. So let's answer the question. What is the probability that a person from the junior class 10 years ago graduated from high school and is happy with their present job? That is this branch here. So graduated and is happy is 0.765. So 0.765. So go ahead and pause the video and try the U-Try. Right, so you should get 0.09. It is this branch. They did not graduate and are happy, 0.09. So we've got a couple more problems that I want to do that we'll just add on the end here. So 5, let's find the probability that somebody is not happy. So to find the probability that somebody's not happy, I'm going to look at my branches that are not happy. So you could either graduate and be happy, or excuse me, graduate and be not happy, or you can not graduate and not happy. So I'm going to add these two numbers together. So this should be 0.085 plus 0.06, which gives me 0.145. Right. 6. Let's now find the probability that somebody graduated given that they're not happy. So here we are only looking at the people that are not happy. We are only considering this group of people. So when I look at this, these are the only two numbers that I'm using. Now it's asking for the probability that they graduated. So my graduated out of this group is 0.085 out of my total not happy. So this will be 0.085 over 0.085 plus 0.06. So I should get 0.085 divided by 0.145, which basically gives us 0.5862. So how is this one different than the last U-try for problem 4 that we did? U-try for problem 4 is the probability that you're looking at a person and determine the probability that they did not graduate and are happy. Here, for 6, we are looking at somebody that is not happy. We know that they're not happy. And then we're going to determine what is the probability that they graduated. All right, I'd like you to try this U-try, find the probability that somebody did not graduate, given that they are happy. Let's go ahead and pause the video and try the U-try. All right, check your answer. Remember, we are only looking at the people that are happy. So here's my happy group. So the probability out of this group they did not graduate is the 0.09, and then you divide them.